Then we move over to reasoning as a causal process. And we already started looking a bit about how you could have this simple form of reasoning. For instance, that if you have a group in your brain for lions, and this group contains also that lions eat humans, then if you meet a lion, you can reason that this lion could also eat you. That could seem like a quite simple thing, but what about logic, etc.? Can that be a causal process? So let's have a look at that. There are different forms of logic, but if we look at sentence logic, it works in the way that you put all sorts of arguments on their logical form, and then sentences are picked out as units, and there are different conjunctions that binds these sentences together. And four basic such kind of logical conjunctions is if then, and, not, and or. So here's an example then. Two typical examples from scientific reasoning. Testing hypothesis put up as an argument. So premise one, if hypothesis A is true, then this and this consequent follows. And then we can do a test to see if the consequent follows, and let's say we get that confirmed in P2, the consequent follows, okay, then the hypothesis is confirmed. Or we could say, okay, if this hypothesis is true, then the consequence B will follow. We do the test and we see that it does not follow, and so okay, we say the hypothesis is not true. So we use these logical conjunctions together with different sentences. It could be if Jones is the murderer, then his fingerprints will match those of the murder weapon, and we check to see they do, so we think he's a murderer, or they don't, so we don't think he's the murderer, would be an example. Could logic like that be put into or turned into a causal process? Well, in computers, we have something called logic gates, where we transform or where we translate these logical connectives then into causal processes. And I've described it here. I'm not going to go into the details. And there are different ways of doing it, but it's a way of translating these arguments that could make it then, if you put in different sentences and the logical connections, then you can get a conclusion as an output. So it could be like switches on or off, or just input 1 and 0. And then it would be very similar to how you can have two neurons that can be activated or not, and then activating or not a third neuron. So this would be a way of translating it into the brain. But I'm not saying that this is how it happens when we reason in our brain. I'm just showing the possibility of turning logic into a causal process. But how does it happen in the brain then? Well, I'm going to make a suggestion here. I'm not an expert. I think this is true, and I'm going to support it with various arguments. But my main point is to show how it's possible to think of reasoning as a causal process. And remember then, if you think that it's not a causal process, you should have another theory about what is reasoning, how does it work, etc. And I'm used to alternative theories not being able to say that at all. So at least here you have a quite detailed theory of how it works with various arguments supporting it. So okay. Let's start by remembering that the brain connects these parts into wholes, as we saw in the previous video. And then remember also how we looked in an old video on understanding, that understanding something is to take apart and integrate it into a larger theoretical framework. So fit it into a whole. And so I said if you can find this larger whole that it fits into, then you understand it. But if you don't, then you either don't understand it, or if you put it in the wrong place, then you misunderstand it. And so the suggestion here then is that reasoning is about sorting which part belongs to which wholes. That is what we do in general when we are reasoning. So we're trying to put together wholes, put parts into wholes into our brain, which matches how parts fits with wholes into the world. So to try to get a correct understanding of the world. When we do reasoning, there are two main forms of reasoning. It's deductive reasoning and inductive reasoning. I'm not going to go into the details, but read if you're interested. The main point is that in deductive reasoning, then if the premises are true, you are guaranteed that the conclusion is true. Whereas in inductive reasoning, even if the premises are true, you can't be guaranteed that the conclusion is true. But that's these two main forms of reasoning. And if we translate that into this idea of reasoning as parts and wholes, then you can say that deductive reasoning is about finding out whether a part belongs to a whole. Because that's how we think of deductive reasoning. We say that in deductive reasoning, then the premises are like a whole and the conclusion is implied in the premises. So it's a part that belongs into the whole that these premises constitute then. So for instance, if I say, this is a classical deductive argument, all humans are mortal, Socrates is a human, that's the two premises, and so the conclusion is that Socrates is mortal. And we can say that, well, we have all humans, they are all mortal, we have Socrates, he's a part of this whole of mortal humans, and so we can conclude by deductive reasoning that Socrates must be immortal. So we're picking this part out of a larger whole. Whereas in inductive reasoning, then we are putting parts together to form a whole. So for instance, we can say that Jones had a motive, Jones' fingerprints were on the murder weapon, etc. We put these parts and all the different evidence together and say, well, the whole is that Jones killed his wife with a knife for this and that motive. And of course, there are extremely many ways of putting parts together and ways of drawing parts out of wholes. So here emotions help us sort out relevant, as we saw earlier also, how emotions help us sort things in our mind to find out what's important. So for instance, if I give another example of deductive reasoning, we could say, okay, all members of tribe X, they want to kill the members of tribe Y, and I am a member of tribe Y. So that's the two premises, that's a whole, and I can deduce or I can reason from that if I meet a member from tribe X, he or she will want to kill me or try to kill me. So that was various forms of reasoning. And then when it comes to questions and answers, that's like having a whole with some parts, but there's some connection is missing. There's a gap that the brain tries to fill in to see if it can make it fit together. So for instance, if I'm wondering about what should I buy my father for birthday, so I see my father birthday present, but what should be in the present, and then I can test out different alternatives. I could give this, but he already has that, or I could give that, but he doesn't like that. I could give that. Well, that's a good thing. He likes it. He doesn't have it. That would fit well into this whole. What I should give my father for birthday, for instance. So the idea then, to put this together, is that we have these general processes of putting parts together into wholes in the brain, but we also have some higher level mechanisms in the brain, such as putting things together at all, or drawing things out, or simulating, trying to fill out gaps. These are sort of general mechanisms that the brain is doing all the time. And we can imagine how through evolution various things have been tested, or various ways of combining, and some have been very poor and very useless. For instance, if it's a kind of reasoning that if I see a lion, it would be a good idea to stick the head into the mouth of the lion, etc. People whose brains work like that, they won't survive. But people whose brains have mechanisms that are efficient in reaching goals, they will survive. So if they reason in ways that are likely to give plausible conclusions, or likely to give conclusions that are true, it is very useful. Finding out what is true about the world is very useful in order to reach goals and in order to survive. So if I'm hungry, I can do this and that, and I will not be hungry anymore. Or if I'm dying, I can do this and that. people who are able to reason in ways that match quite well with reality, they will survive. So if they get mechanisms like that in the brain, it's good. And that can sound like just I'm waving my hand here, but we do have a lot of evidence that the brain works in these ways, but often not perfect, often in quite efficient ways, but not perfectly rational, but in ways that very often gives quite good conclusions. So if you read Daniel Kahneman's book Thinking Fast and Slow, you'll find plenty of examples of how of non-rational reasoning, but this is how our brains have evolved, finding various ways of reasoning that works quite well. And of course in logic we have found even better ways, but just through evolution and the evolution of brains, these mechanisms together, the causal processes just of connecting parts into wholes, and these mechanisms for simulating, deducting, filling in gaps, etc. Together, it's not a determined causal process, A, B, C, D, but it is causal processes with dispositions, and where either this or that will lead to either this or that, and it's structured in a way that makes it possible that you can both have a causal process, but also that the result of these causal processes can be rational, reasonable results, help us give a true understanding of the world. So a short foreshadowing in the end also when it comes to choices, because many people will also think that, well, freedom is an important, or making choices is a part of this causal process, and we'll get back to choices, but just briefly how to think of a choice also as a causal process. The idea is then that you can see something, sense something. This can activate various alternatives from memory, and which again activates different desires, which again activate different memories with different feelings, which again can change the strength of the desires. And but at one point, a desire reaches a certain threshold, which then makes it the case that the brain sends and signals to the motor neurons moving the body to say, start now doing this action. We'll get back to more evidence for that as well. But for now, the general idea was to give a detailed explanation of how reasoning could occur in the brain as a causal process and still give us reasonable conclusions or make rational choices. And so that's the main presentation of the theory, and then we'll look at several objections in the following videos, which will then further clarify how I'm thinking and how we can think of reasoning as a causal process.